Pretend you were a physics student. You were just getting out of class. You were walking home when you remembered that there was a Galaxy Wars marathon on tonight. So you'd do what every physics student would do. Run. You're pretty motivated to get home, so say you start running at 6 meters per second. Maybe it's been a while since the last time you ran, so you have to slow down a little bit to 2 meters per second. When you get a little closer to home, you say, "No. Captain Antares wouldn't give up, and I'm not giving up either," and you start running at 8 meters per second, and you make it home just in time for the opening music. These numbers are values of the instantaneous speed. The instantaneous speed is the speed of an object at a particular moment in time. And if you include the direction with that speed, you get the instantaneous velocity. In other words, 8 meters per second to the right was the instantaneous velocity of this person at that particular moment in time. Note that this is different from the average velocity. If your home was 1,000 meters away from school and it took you a total of 200 seconds to get there, your average velocity would be 5 meters per second, which doesn't necessarily equal the instantaneous velocities at particular points on your trip. In other words, let's say you jogged 60 meters in a time of 15 seconds. During this time, you were speeding up and slowing down and changing your speed at every moment. Regardless of the speeding up or slowing down that took place during this path, your average velocity is still just going to be 4 meters per second to the right, or if you like, positive 4 meters per second. Say you wanted to know the instantaneous velocity at a particular point in time during this trip. In that case, you'd want to find a smaller displacement over a shorter time interval that's centered at that point where you're trying to find the instantaneous velocity. This would give you a better value for the instantaneous velocity, but it still wouldn't be perfect. In order to better zero in on the instantaneous velocity, we could choose an even smaller displacement over that even shorter time interval. But we're gonna run into a problem here, because if you want to find a perfect value for the instantaneous velocity, you'd have to take an infinitesimally small displacement divided by an infinitesimally small time interval. But that's basically 0 divided by 0, and for a long time, no one could make any sense of this. In fact, since defining motion at a particular point in time seemed impossible, it made some ancient Greeks question whether motion had any meaning at all. They wondered whether motion was just an illusion.